The difference between observational and experiment: observational, you observe. You do not influence in any way. Experiment, you give something that is going to change a behavior. You have a control group, you have a treatment group. The difference between a random sample and a simple random sample: in a random sample, every person has the same chance of being selected. In a simple random sample, you get more than one sample. Every sample size will be the same, and every sample will have the equal chance of being selected. True or false? A placebo is an actual treatment. False. It is the fake treatment. It's this substitute that we give them. We don't give them the treatment. This is what comes from our control group. Number 7, using a systematic sample guarantees that members of each group within a population will be sampled. Well, that's false for systematic. This is your stratified. Think of some freshmen, some sophomores, some juniors, some seniors. Samples from each group, the equal samples from each group. Number 9, the methods for selecting a stratified sample is to order a population in some way and then select members at regular intervals. This is your systematic. Count off 1, 2, 3, 1, 2, 3. Pick all your 3s. Systematic, regular intervals. Number 11. In a survey of 177,237 U.S. adults, 65% of those surveyed said they visited a dentist in the last 12 months. Even though this is a survey, this is observational. You didn't influence it in any way. To study the effect of music on driving habits, 8 drivers, 4 males, 4 females, drove 500 miles while listening to different genres of music. This is experimental because you are changing their music and you want to see how they react. Classical may make them drive nice and slow. Maybe a hip-hop will make them drive a little faster or a little happier. A pharmaceutical company wants to test the effectiveness of a new allergy drug. The company identifies 250 females, ages 30 to 35, who suffer from severe allergies. This is what they have in common. The subjects are randomly assigned into 2 groups. This is your control group versus treatment group. One group is given a drug, the other group is given a placebo that looks exactly like the drug. This is a blind experiment. They do not know what they're getting. After 6 months, the subject's symptoms are studied and compared. The experimental units are the females, the 250 females aged 30 to 35, and they're being given a new allergy drug, and the other part is being given the placebo. A potential problem could be a little bit of bias on the part of the researcher. You really maybe would want to make this double blind so that the researcher doesn't also know who's getting the drug. Normally, the researcher makes sure that this is done right because they've already invested a lot of time, money, and effort into this. But there always is a little bit of bias that we can't control. A footwear company developed a new type of shoe designed to help delay the onset of arthritis in the knee. 80 people with early signs of arthritis volunteered for a study. 1/2 of the volunteers, 40, were the experimental shoe treatment group, and the other half, 40, is the control group. They wore placebos. They thought they were wearing the shoe, but they weren't. This is the blind part of the experiment group. The individuals wore the shoes every day, and at the conclusion of the study, their symptoms were evaluated, and the MRI tests were performed on their knees. They wanted to see if they see improvement, or at least a delay in the arthritis. Your experimental units are your 80 stages in the early stages of arthritis, and they put on an experimental shoe. One possible problem is this may be too small. If you're testing something that has such an effect on people and you want to market this, you certainly want to test more than 80 people. And in actuality, you only gave this to 40. So you may want to replicate this, more repetition. You may want to increase your sample size. And to make it double blind, don't forget the researcher also doesn't know. It's just given a box of A and B, shoes, and he hands them out to the groups. And then at the end, he's told. Blocking, because you don't want to separate your groups into male and females, you would want to make 40 males and females in each group, and then maybe within here, block the men and the women within each group, but never keep two groups of completely separate men and women. Again, using your table to generate your numbers, mark them off between 1 and 90. And in your table, every 2, mark it off and count how many you get between 1 and 90. Kick out the ones that are greater than 90, and there shouldn't be too many in this case. Any duplicates, kick those out and keep counting. To generate these in your calculator, you're going to go to Math, Probability, and Random Integer. It's going to say the start, 100, the finish, 150, and I wanted 15 numbers. Now, because you can get duplicates, you might want to change this to 20 numbers and just take the first 15 unique numbers. A researcher wants to study the effect of sleep deprivation on motor skills. They selected 18 people. They use a random number generator to choose 9 subjects for the treatment group. The other 9 will go into the control group. Your random number generator, again, set it from 0, 1 to 18. You may have to do this quite a few times because up to 18 is a small amount of numbers. But you want to pick the first 9 that you get in your table that are unique and put them in a treatment group. The remaining 9, put them in your control group. This might take a little longer in your table because you can only go up to 18. Okay, identify your sampling techniques. You have stratify, systematic, random number, cluster, convenience. Okay. Using a random number, a digit dialing, researchers call 1,400 people and ask them about their obstacles, blah, blah, blah. Random, simple random sampling. Everybody has an equal chance of being selected. The only problem, the only bias, might be that not everyone owns a landline when you call. A lot of times, older people don't have cell phones, but they have landlines. Younger people tend to just use their cell phones. So that could be a possible bias. Number 25, questioning students as they leave a university library. A researcher asked 358 students about their drinking habits. That's a convenience, because when they leave a library, they were studying. Chances are they weren't out drinking, and they're probably not big drinkers. So that has a little convenience and a little bias in it. After a hurricane, a disaster unit is divided into 200 equal grids. They just took the grids and divided everybody into equal spaces, 200. 30 of those grids are selected, and they're selected at random. And every occupied household in that grid is interviewed. Everybody in this grid is interviewed. This is a cluster where you take a part of this, like a zip code, and you interview everybody in that cluster. Therefore, not all of these pieces get represented. All of these that are blank, they don't get represented. And maybe they were a little bit different. Maybe there's a little bit of bias there. Chosen at random, 580 customers at a car dealership are contacted and asked the opinions of the services they received. You might think this is convenient, but you want to be at a car dealer because those are the ones that received your service. You have to ask them. So this is simple random sampling. However randomly they did it, they assigned numbers to their sales, they picked them out of a hat, they generated the numbers through a sequencer, they did this randomly. Number 28, every 10th person entering a mall is asked to name his or her favorite store. This is systematic. You put them in some kind of order and you take them at regular intervals. Now the only thing is he or her may like that mall and like a particular store there, and then you're not going to get somebody that represents a different store that's not in that mall. The last one, soybeans are planted on a 48-acre field, and the field is divided into 1-acre subplots. So again, it's kind of like the other one. We divide everything into subplots. A sample is taken from each of the subplots. This is your stratified. See the difference between this one and this one? This is your stratified.